And this is where factoring works out well for us, because factoring allows us to cancel. It'll also allow us to recognize non-permissible values. So let's move ahead with that. On the top, we have 3x, and again, factoring on the bottom where we can. So we could pull a 2 out of there, and we're left with 2x minus 3. And on the right part, we have our 2 by itself. We could pull out an x out of that and be left with x minus 1. And so from a simplifying point of view, we recognize that we can cancel 2's, which is nice. We also recognize that we can cancel the x's. Now, one thing we do note is when we get to the non-permissibles, we do have to remember that that x was there. So even if we can cancel it out at this point, we still have to remember it when we get to the non-permissibles. So you could make a little note there that x cannot equal to 0 because it was on the bottom there. So moving along from a simplification point of view, we have a 3 on the top, we have a 2x minus 3 on the bottom, and we also have an x minus 1 on the bottom. So there's our simplified version. Now getting into non-permissibles. So we already have one non-permissible that we made a note of already. The other non-permissibles are still evident here, and one of them is 2x minus 3 can't equal 0. We could work that out like this and say 2x cannot equal 3, or x cannot equal 3/2, dividing both sides by 2. And we have one more non-permissible value, and that would involve making sure that x minus 1 is never 0. So that one we can just add 1 to both sides and say, x cannot equal 1. And that would be our third non-permissible value.